Okay, so uh, anyone who's ever struggled to get their Wi-Fi to work knows that wireless communication is kind of a big deal.
Yeah.
But we're talking about way more than just getting a good signal, right?
Right.
We're talking about the technology that's connecting billions of devices and changing how we live, work, everything. So to help us, really wrap our heads around all of this, we're diving into some pretty fascinating research today from Professor Hala Merriam.
And his work is really essential reading for anyone who wants to understand, well, where wireless communication is going, because it really builds on where it's been.
Absolutely. And he really lays out like the complete picture from the early days of like radio to the mind-blowing potential of the Internet of Things. So are you ready to get our wireless geek on?
Oh, absolutely. Let's dive in.
Okay, perfect. So Professor Hala Merriam starts off by highlighting just how quickly wireless tech has evolved. And it's honestly kind of mind-blowing when you think about it. I mean, it wasn't that long ago that, mobile phones, they were like these clunky things that you could like barely make calls on.
Yeah.
And now we're carrying around these supercomputers in our pockets that can like stream HD video and like connect us to pretty much anyone in the world.
It's crazy. And it all happens so fast.
And Professor Hala Merriam, he points out that in 1990, there are only like 11 million cell phone users globally.
Yeah, I remember reading that.
Can you believe that?
It's wild, right?
And today there are over 7 billion.
Just mind-blowing.
Yeah.
Yeah.
It's insane growth.
It is.
And it really shows how quickly, wireless tech went from like this niche thing to something that's just like completely essential to like modern life.
It's the backbone of everything now, really.
Yeah. It really is. And what I find like even more fascinating is how we've moved beyond just using it for like calls and texts, like we're talking about streaming, gaming, like real-time data transfer, all wirelessly.
And even beyond, think about the Internet of Things.
Right.
That's like the next frontier. We're talking about a future where like everything is connected, not just our phones, but like our cars, our appliances, even like our coffee makers.
Yeah, it's a lot.
It's huge.
And Professor Hala Merriam, like he really dives into the numbers.
He does.
And some estimates predict like 100-fold increase in the number of connected devices in the next few years.
Yeah, at least.
That's wild.
It'd be interesting to see how it all plays out.
To say the least, yeah.
Yeah. But before we get too far ahead of ourselves, I think it's important to like take a step back and really understand the fundamentals of how wireless communication actually works. Because like we use it every day, but I feel like most of us, including myself, don't really like get the technical details.
Yeah, it's easy to take it for granted.
Yeah, it is.
But there's a lot going on behind the scenes.
Right, and that's what Professor Hala Merriam really gets into in his work, is how we went from like these very basic forms of wireless communication to the incredibly complex systems that we have today.
And he starts by going back to the basics, like the very first generation of cellular networks, which was analog.
Yeah.
And, all it could really handle was voice calls.
Right.
Like those old brick phones you see in like 80s movies. That was 1G.
Right. And it's funny because like even though it was so limited compared to what we have now, it was still like revolutionary at the time.
Absolutely. It was like magic, being able to make a phone call from like anywhere.
Right.
It was incredible.
Right.
And then, of course, came 2G, which was digital. And that was a huge leap forward because it allowed for things like, text messaging and like very basic mobile internet.
And 2G was interesting because it's when we started to see like different standards emerge.
Right.
Like GSM, CDMA, TDMA, and each of these standards had like its own quirks and limitations.
Yeah, it was kind of the Wild West of mobile internet back then.
It really was.
Like slow, unreliable, but like super exciting because it was like the first glimpse of what was possible.
And it paved the way for 3G, which was a total game changer.
Oh yeah, 3G, that was huge. I mean, that's when we finally got like true mobile internet.
Right, with packet switch networks and speeds that actually made it possible to like browse the web and use apps on our phones.
Yeah, and 3G wasn't just one thing either. There were like all these different technologies competing for dominance.
That's right, like UMTS and CDMA 2000,
right.
Each with their own, strengths and weaknesses.
And then we got 4G, which like blew everything that came before it out of the water.
Oh, yeah, 4G was a whole other level.
It was like night and day.
It was like going from like dial-up to broadband.
Yeah, exactly.
That was incredible.
And Professor Halem, he talks about how 4G was made possible by a lot of breakthroughs in like signal processing and network architecture. Like he specifically mentions OFDM, which is this like frequency division multiplexing scheme that like drastically improved spectral efficiency.
It was a game changer.
It really was. And suddenly we were talking about mobile internet speeds of like up to 100 mil apiece.
Yeah, which was like unheard of at the time.
It was insane.
And those higher speeds, I mean, they just opened up a whole new world of possibilities for mobile devices.
Right, like that's when we saw the explosion of like streaming services.
Like Netflix and Spotify.
And online gaming and all these like data-intensive applications that we, just take for granted now.
Yeah, it's pretty amazing to think about.
It really is.
Yeah.
But before we get too deep into the wonders of, high-speed mobile internet,
yeah,
I think it's important to acknowledge that, like, wireless communication, for all its, like, incredible advances,
right,
it's not without its challenges.
It's not perfect, that's for sure.
Yeah, and that's something that Professor Halem really emphasizes in his work. So maybe you can, like, talk a little bit about some of the inherent challenges of sending signals through the air.
Yeah, so, like, imagine you're trying to have a conversation with someone in a really noisy, crowded room. It's hard to hear, right?
Yeah.
Your voice has to compete with all the other sounds. Yeah. And the further away you are from the person you're talking to, the harder it is to make yourself heard.
Right.
Well, wireless signals, they face the same kind of problems,
right,
but on a much larger scale.
Yeah, that makes sense.
So you've got interference from other devices, natural noise from things like lightning storms, even just like the random motion of electrons in the atmosphere.
So it's like a constant battle against like the elements and everything else that's trying to use the airwaves.
Exactly. Oh. And then you've got the issue of like signals bouncing off buildings, going through walls, all sorts of things that can distort the signal and make it harder to transmit data reliably.
Yeah, it's like the more I learned about this, the more I'm amazed that it works at all.
I know, right?
Like it seems like it would just be this like garbled mess.
It can be. Which is why engineers have had to come up with all sorts of clever solutions to overcome these challenges.
Right, and that's what's so fascinating about this field is that it's like this constant like back and forth between, the laws of physics and human ingenuity.
Absolutely.
So like how do engineers actually like design systems that can reliably transmit data through all this, like chaos?
Yeah, well, one of the key techniques is something called modulation.
Modulation, okay.
And it's basically about finding clever ways to encode information onto a radio wave.
Okay, so like changing the frequency or the amplitude of the wave.
That's exactly it. And there are actually lots of different ways to do this, different modulation schemes, as they're called.
Okay.
And each one has its own, like, strengths and weaknesses.
So, like, some are better suited for, like, noisy environments, while others might be more efficient in terms of, like, how much data they can transmit.
It's all about trade-offs.
Right.
And it gets even more complicated because, like, the best modulation scheme to use, it can actually change depending on the environment.
Oh, wow.
Like, if the signal is strong and clear, you might use one scheme. But if it's weak or there's a lot of interference, you might need to switch to a different scheme that's more robust, but maybe not as fast.
So it's like the system has to be able to, like, adapt on the fly.
Exactly.
Wow, that's pretty impressive.
It is, and it's one of the things that makes wireless communications so complex.
But even with, like, all this clever modulation stuff, isn't there still a chance that, like, some data might get lost or corrupted during transmission?
Oh, absolutely.
Especially in, like, noisy or congested environments.
Yeah, and that's where error correction coding comes in.
Right, okay. I remember learning a little bit about error correction codes in, like, my algorithms class, but it's been a while.
Yeah, it's one of those things that sounds really abstract until you realize, like, how essential it is.
It's like the foundation of so much of the technology we use every day.
Totally.
But can you remind me, like, how error correction codes actually work?
Yeah, so basically the idea is to add some redundancy to the data so that even if some bits get flipped during transmission, the receiver can still figure out the original message.
Okay, that makes sense.
It's kind of like if you were sending a really important message by mail, you might make a copy of it just in case the original gets lost.
Right.
Error correction codes do something similar, but with data.
Okay, so it's like sending multiple copies of the same information.
Sort of. But instead of sending exact copies, It sends out these like encoded versions of the data. And by combining the information from all these encoded versions, the receiver can actually reconstruct the original data, even if some of the encoded versions have errors.
Wow, that's really clever.
It is, and there are like tons of different types of error correction codes.
I like that.
Each with its own like level of complexity and effectiveness.
And I'm guessing that choosing the right error correction code depends on like the specific application.
Exactly. Like if you're streaming a video, you might be able to tolerate a few errors here and there because the human eye can't really perceive them.
Right.
But if you're transmitting like financial data or medical records, obviously you need a much higher level of accuracy.
Right. You don't want any like drop digits or anything like that.
Exactly.
So it's all about like finding the right balance between like reliability, efficiency, and complexity.
You got it.
This is all starting to sound incredibly complex.
It can.
Like, how do engineers even begin to like design and implement these systems?
Well, it requires a deep understanding of like signal processing, communication theory, information theory, all sorts of really cool stuff.
I bet.
But the cool thing is that as software engineers, you'll be working with these concepts all the time.
Oh, really?
Even if you're not like designing the physical layer protocols yourself.
What do you mean?
Well, think about it. When you're writing code that communicates over a wireless network, you need to be aware of the limitations and capabilities of that network.
Okay.
You need to understand things like latency, bandwidth, error rates, and how they might affect the performance of your application.
Right. Like you might need to design your application to be more tolerant of like delays or interruptions in the network.
Exactly.
Or to like use data compression techniques to reduce the amount of data that needs to be transmitted.
Yep, all of that.
Wow. Okay. So even if we're not like designing the nuts and bolts of the wireless protocols themselves, having a good grasp of these underlying concepts can really help us write better, more efficient code.
Absolutely.
That's really interesting.
It's all connected.
It is. It really is. And it just highlights how important it is to like have a broad understanding of all these different areas of computer science.
Totally agree.
Because you never know when you might need to draw on knowledge from like one area to solve a problem in another area.
That's the beauty of this field. It's all interconnected.
It really is. And Professor Hale-Merriam, he really drives this point home in his work.
He does.
Like he's constantly drawing connections between like these seemingly disparate concepts.
Yeah, and he does a great job of like explaining it in a way that's accessible.
He does. He really does. And I think that's like one of the things that makes his work so valuable.
I agree.
Is that he's able to take these like really complex ideas and make them understandable to a wide audience.
That's a real skill.
It is. And it's something that we as like educators and communicators should all strive for.
For sure.
Because if we want more people to be engaged with these like really important technologies, we need to make them less intimidating and more approachable.
Absolutely.
And I think Professor Hale-Merriam's work is a great example of how to do that.
I agree.
So before we move on to the next part of our discussion,
yeah,
I just want to like quickly recap what we've covered so far.
Sounds good.
So we started by talking about like the incredible growth of wireless communication.
Yeah.
And how it's gone from like this niche technology to something that's just like completely ubiquitous.
Right.
And we talked about how this growth has been driven by like a series of technological breakthroughs from like the early days of analog cellular to like the high-speed mobile internet that we have today.
Yep.
And we also touched on some of the inherent challenges of wireless communication.
Like interference and signal distortion.
Right.
Those are big ones.
Yeah. And how engineers have developed all sorts of clever techniques to overcome these challenges, like modulation and error correction coding.
It's pretty remarkable when you think about it.
It really is. But as we've been alluding to, the story of wireless communication, it doesn't end there.
Not even close.
In fact, you could argue that it's just beginning.
Absolutely.
Because we're now on the cusp of this whole new era of connectivity.
The Internet of Things.
Right. And that's what we're going to be diving into in the next part of our discussion.
I mean, good.
So buckle up, everyone.
That would be a wild ride.
Because things are about to get really interesting.
Very interesting.
Okay, so the Internet of Things.
Yeah, the IoT.
It's like this buzzword that gets thrown around a lot these days.
It's everywhere.
But I feel like, a lot of people, myself included, we don't really have a good grasp on like what it actually means.
Yeah, it's one of those things that like everyone's talking about it, but not everyone really understands it. Like they might have heard the elevator pitch, like, oh, it's all about connecting everyday objects to the internet. But they don't necessarily like get the full implications of that.
And it can be easy to like dismiss it as like, oh, it's just like, smart fridges and thermostats that I can control with my phone.
We're like, is that really going to change the world?
Yeah.
But it's so much bigger than that.
So like, what is it about the IoT that gets you so excited?
Well, for me, it's the sheer scale of it. Like we're talking about potentially billions of devices, all connected and communicating with each other.
Yes.
And those devices, they're not just like passive sensors. They're also actuators, meaning they can like take actions based on the data they collect.
Okay, so it's not just about like collecting data. It's about like using that data to actually do something.
Exactly. And that's where things get really interesting.
Because
it opens up all sorts of possibilities for like automation, optimization, you name it.
like, give me an example.
Okay, so like imagine a smart city where all the traffic lights, all the cars, all the parking spaces, they're all connected and communicating with each other.
Okay.
So the traffic lights, they can adjust their timing in real time. Based on traffic flow. Cars can like automatically find available parking spots. And the whole system is just like constantly optimizing itself to reduce congestion and improve efficiency.
That would be incredible.
Right. And that's just one example. You can imagine similar applications in like healthcare, manufacturing, agriculture, you name it.
So it's like the IoT has the potential to like revolutionize pretty much every industry.
I think so.
Wow.
And it's already starting to happen.
So like what are some of the key technologies that are making the IoT possible?
Well, obviously, wireless communication is a big one.
Right.
I mean, you can't have a network of interconnected devices if they can't talk to each other.
Right.
And we've already talked about some of the challenges of wireless communication.
Yeah, like interference, signal distortion, all that fun stuff.
Right. But in the context of the IoT, these challenges become even more pronounced because you've got so many more devices all competing for the same limited bandwidth.
Right. It's like if you thought your Wi-Fi was bad before, just wait till you've got like 100 devices in your home.
Yeah, it's going to be a mess. Unless we can find ways to like use the available spectrum more efficiently.
So like what are some of the ways that engineers are trying to address that challenge?
Well, one approach is to use like lower power, shorter range communication protocols.
Okay.
Like Bluetooth Low Energy or Zigbee.
Right.
These protocols, they're not meant for like streaming HD video or anything, but they're very energy efficient.
Right.
And they're well suited for applications where you just need to transmit small amounts of data over short distances.
Okay. So like for sensors and actuators that are like physically close to each other.
Exactly.
That makes sense.
And then there are also like newer cellular technologies.
Yeah.
Like narrowband IoT and LTE Cat-M1,
Right.
which are specifically designed for IoT applications.
And how are those different from like regular 4G or 5G?
Well, they're optimized for like low data rates,
Okay.
long battery life,
Right.
and wide coverage.
Okay. So like they're not going to be as fast,
Right.
but they're more energy efficient and they can reach devices that are in like remote locations.
Exactly.
Got it.
And then, of course, there's also a lot of work being done on like cloud computing and edge computing.
Right, because you need somewhere to like store and process all the data that's being generated by all these devices.
Right. And that's where the cloud comes in.
So like the cloud can act as like the brains of the operation.
In a way, yeah. It can like collect data from all the devices, analyze it, and then send instructions back to the devices.
Okay, that's cool.
And then edge computing, that's kind of like bringing some of the intelligence closer to the devices themselves.
Okay, so like instead of sending all the data back and forth to the cloud,
Right.
you can do some of the processing locally.
Exactly, which can reduce latency and improve efficiency.
Okay, that makes sense.
So, as you can see, there's a lot going on in the world of the IoT.
It's a lot to wrap your head around,
It is.
but it's also incredibly exciting
It is.
because it has the potential to like fundamentally change the way we live, work, and interact with the world around us.
I totally agree.
So it sounds like the IoT, it's not just about connecting devices, it's about like rethinking how we design and build systems.
Exactly. It's a whole new paradigm.
And it's one that comes with like a whole new set of challenges.
For sure.
And as someone who's, studying to be a software engineer, this is like both exciting and a little daunting.
Oh, I get it. It's like you're learning all these tools and techniques, But the rules of the game are constantly changing.
Exactly. So, like, how do we even begin to prepare for this, like, this future of hyperconnectivity?
Well, I think the first thing is to, like, really embrace the idea of lifelong learning.
Okay.
The tech industry, it's always evolving. And the IoT is only going to accelerate that. So, even after you graduate and get a job, you're going to need to constantly be learning new things.
So, like, don't be afraid to, like, dive into new programming languages.
Or,
or, like, learn about new protocols and technology.
Yeah, and don't be afraid to experiment. Like, get your hands dirty, build some stuff.
Right.
Break some stuff.
Yeah, I like that.
That's how you learn.
And it's not just about, like, the technical skills either.
Right.
Like, we also need to be thinking about the ethical and societal implications of the IoT.
Absolutely. This is huge.
Because, like, this technology has the potential to be incredibly powerful.
It does.
And with great power comes great responsibility.
It's a cliche for a reason.
It is. But it's true. Like, we need to be thinking about things like privacy, security, and equity. Because we don't want to create a future where, like, only a select few have access to the benefits of this technology.
Right, or a future where our every move is tracked and monitored.
Exactly. So, like, how do we ensure that the IoT is used for good?
Well, I think it starts with having these conversations. Like, we need to be talking about these issues openly and honestly, and we need to involve a diverse range of voices in those conversations.
Right, like, not just engineers and tech CEOs.
Exactly. We need ethicists, sociologists, policymakers, everyone.
Because this is a conversation that affects all of us.
It really does.
And it's one that we need to have now.
Before it's too late.
Right, because once these technologies are out in the world, it's much harder to, like, put the genie back in the bottle.
Exactly.
Wow. Okay, this has been, like, a really thought-provoking conversation.
I'm glad you think so.
I feel like I've learned so much, not just about, like, the technical details of wireless communication and the IoT, but also about the bigger picture implications of this technology.
That's what we were going for.
And I think it's really important for us as students, as future software engineers, to be thinking about these things.
Yeah, absolutely.
Because we're the ones who are going to be building this future.
We are.
So, like, let's make sure it's a future that we can all be proud of.
I'm with you on that.
Well, on that note, I think it's time to wrap things up. So, to all of our listeners out there, thanks for joining us on this deep dive into the world of wireless communication and the Internet of Things. We hope you found it as fascinating and thought-provoking as we did. And we'll catch you next time for another exciting exploration of the technologies that are shaping our world.